Just want to run through one more example of rational equations with you, just to give you a little bit more variety in what you're seeing, so that when you go and practice the homework, you'll have just a little bit more experience of seeing some different things that could show up. These rational equations do tend to be kind of diverse, and so they're not all the same. And so I just want to give you a little bit more to work with. So this next one, we've got three denominators, three fractions. And remember the 6 steps here: find the LCD, multiply both sides by the LCD, reduce the fractions, simplify and solve, check answers, write the solution set. We're going to stick to those 6 steps. And so the first thing we need to do is find the LCD. Remember, to find an LCD, we've got to factor all the denominators and then look to see what denominator or what factors are missing for each one. Okay, so this first, the first 2 denominators are both x minus 2. Those don't factor. So the first one we need to actually factor is this last one, 4x squared minus 8x. And of course, when we factor that, 4x squared minus 8x, there's a common factor of 4x, so I'm going to pull that out. And we're going to be left with an x minus 2. Okay, so notice now, if this denominator on the right is 4x times x minus 2, the other ones are just x minus 2. Clearly the LCD is going to need an x minus 2. All of them contain that factor. So the LCD must have an x minus 2 in it. But we also need the 4 and the x, right? Those 2 factors can't be left out. And so, well, I guess I could write it in the order that I have it written already. It doesn't really matter, but I'm going to write it as 4x times x minus 2. All those factors must be included, and the x, or none of them have any exponents on them other than 1. And so we're not really concerned about getting their largest power or anything that we have been concerned about with LCD. So this is good, 4x times x minus 2. So second step is to multiply both sides by that LCD. Remember that when multiplying both sides, the LCD will distribute to every term, so we're going to do this 3 times. The first one gets multiplied, and I'm going to leave this in its factored form so that it's easier to cancel in the next step. Here we're going to have another 4x times x minus 2, and here we'll have another 4x times x minus 2. Now remember, this denominator is already essentially 4x times x minus 2, it's just not factored, okay? So those are the same thing. So now I'm going to go ahead and cancel or reduce my fractions. And to do that, the x minus 2's will cancel off here and here. And over on this side, everything cancels off in the denominator, right? So the 4's cancel, the x's cancel, and the x minus 2's cancel. And that essentially eliminates that entire denominator. So the resulting equation is going to be 4x times x, which is 4x squared, minus 4x times 1, which is 4x. And that's going to be equal to, well, the only thing left over here is a 3. The denominator's gone and everything else on top is gone. Okay, so I'm left with this kind of basic polynomial equation. We've seen how to solve polynomial equations using factoring. And so to do that, we're going to get a 0 on one side of the equation. Okay? To get a 0 over there, I'm going to subtract the 3 from both sides. Now I have all unlike terms on the left, so I have to keep them separate. 4x squared minus 4x minus 3 equals 0. Okay, so here I have a polynomial equation with a 0 on one side. Remember, to solve these, you have to utilize the zero factor property. Okay, and the zero factor property just says that when you factor this polynomial, you set the individual factors equal to 0. Okay, because if 2 things multiplied equals 0, then at least one of those things must be 0. So here we'll go through and do that. But this, to factor this, remember it's a trinomial with a lead coefficient that is not 1. So we're going to use the modified AC method. That's the method I'm going to choose on this one. And remember, the modified AC method starts out, I'll just give my general structure in here, 2 binomials equals 0. And we're going to take, instead of 4x squared here, we're going to write it as 4x and 4x. And then we need to take a times c and figure out factors of AC that will add up to the -4 in the middle. So we know AC is -12. And so factors of -12 that add up to -4. Well, think about, you've got 1 and 12, and obviously something's got to be negative in there. The bigger one will be negative. So 1 and -12, 2 and -6, 3 and -4. Those are the only options, and it's the 2 with the -6 that add up to the -4. So we put those in the parentheses, +2, -6, and remember, with the modified AC method, we've got to get rid of any common factors, right? So anything that's a common factor within these sets of parentheses. So here in this first one, there is a common factor of 2. We've got to divide that out. And in the second set of parentheses, there's also a common factor of 2. We have to divide those out. And what we'll be left with is a 2x plus 1 and a 2x minus 3 equal to 0 when we divide those out. Okay? So now we have two factors that, when multiplied together, would give us 4x squared minus 4x minus 3. But now their product is equal to 0, which means at least one of the two must be 0. So we set each of them equal to 0 separately. And solve the corresponding equations. Well, here, and I'll do these without showing all the detail, but here you would subtract a 1 and then divide by 2, and you'll be left with x equals -1/2. Here you would add the 3 and divide by 2, and you'll be left with 3/2. Okay, so you guys should be able to see those develop there. So -1/2 and 3/2. Now remember, all I've gotten through is simplifying and solving. Now we've got to check our answers. And remember, the main thing here is to check and make sure that neither of these numbers make the denominator 0 in the original equation. Well, if I look at the original equation, there's only a couple things that would make the denominator 0, right? This first one, a 2 would make the denominator 0 because 2 minus 2 is 0. Here the same thing, 2 minus 2 would be 0. And here, if I put a 0 in, both terms would end up being 0, and so that would be 0. And if I put a 2 in, I would get 16 minus 16, which is also 0. So the only things that we really need to avoid, I'll write this up here, we have to avoid x equals 2 and 0. Those are the two numbers we can't have, okay? You might say that those are what are excluded from the domains of each of the rational functions, if you're thinking of them as functions. And so if they're excluded from the domains, they cannot be a solution to the equation. In our case, -1/2 and 3/2, neither of these will make the denominators 0, okay, because they're not on this list. And if you plug them in, you'll see, right, -1/2 minus 2 is -2.5. And you could go through the list. 3/2, so I would plug it in. 3/2 minus 2 would be -1/2, and so forth. You're not going to get a 0 on any of those. So our final solution set, right? We've got to have a solution set. It's actually going to contain two answers now, both -1/2 and 3/2. Okay. So our final solution set has two answers. Both of them work. There may be times, and I should mention this, there may be times where you solve a rational equation and you get multiple answers, like two of them, where one of them works and one of them doesn't. Okay, that is a possibility. And so you could end up with multiple answers down here, but only one number in the solution set. So you really have to check both of them, not just one of them. Okay, it's going to be very important for you. I don't have another example for that right now, but I just wanted to mention that you do want to make sure to check your answers every time and check all of them, because you could have one or more of them. Maybe it could be the case that neither of these work. Okay, so there's lots of options, and just you want to make sure that when you get to the final answer, you've included in your solution set only those answers that do not make the denominator 0.